Alright, so in this video, we're going to be going over kinematics. And all that really means is we're going to learn how position, velocity, and acceleration are related. So the first thing you need to know is that acceleration is equal to the derivative of velocity with respect to time, and velocity is equal to the derivative of position with respect to time. So if you had the position of a particle given by the relation of this equation right here, s of t equals 6t squared minus 3t minus 1, and you wanted to find the velocity and acceleration, you can just take derivatives. So velocity is going to be equal to the derivative of position with respect to time. So we're just going to take the derivative of that equation there. And so we'd get 12t minus 3. And then acceleration would be the derivative of velocity with respect to time. So we're going to take the derivative of this now, which is just 12. Now, if you wanted to find position, velocity, and acceleration at a given time, let's say t equals 3 seconds, then we can just plug 3 in for t into each of these equations. So position at 3 seconds would be 6 times 3 squared minus 3 times 3 minus 1, which would be 6 times 9 minus 9 minus 1, which is 54 minus 9 minus 1, which is 44. All right, and the units on this would be whatever the declared units on position would be. We'll just say it'll be feet. So this would end up being 44 feet per second. And then for velocity, we would get 12 times 3 minus 3, which is 36, minus 3, which is 33 feet per second. Sorry, up here it would just be feet because it's position. Velocity is in feet per second. And then acceleration would just be 12 feet per second squared. All right, so go ahead and try one of these on your own. Let's say our position equation is 3t squared minus 6t plus 9, and just find velocity at 3 seconds. All right, so go ahead and pause the video, work that out, and then you can check your solution with the PDF. That'll be number 1. All right, so now let's talk a little bit more about these kinematic equations. If you take these basic equations, just the general form, you can actually like split these and take integrals, and what you'll end up with are these equations right here. You can get v equals v naught plus at, s equals s naught plus v naught t plus 1/2 a t squared. V squared equals v naught squared plus 2a s minus s naught. Now, the one thing you need to remember about this is that acceleration is constant in order for these to work. All right. Also, anything with like this not after means initial. So v naught would be initial velocity, where v would just be the final velocity. Sometimes if it's easier to remember, you can write them as like v2 equals v1 plus at. So this would be velocity at position 1, velocity at position 2, and so on, if it's easier to remember it that way. But these can help you solve problems. For example, like this one here. If we had a walker and they were walking at a rate of 1.5 miles per hour, and they walk a total distance of 2 miles with final pace of 4 miles per hour. If they accelerated at a constant rate, what is that acceleration? And how long did it take them to walk the 2 miles? All right, so when I get questions like this, I like to split things up into things that information that was given to me, and then information that I'm trying to find. Okay, so I know that v naught equals 1.5 miles per hour, v equals 4 miles per hour, and s naught equals 0 miles, because that's where we're starting to measure our increase in acceleration. And so then s would be that final 2 miles. And then we're trying to find acceleration and time. So if I go back and look at these equations here, we can kind of start to look at what we're given and what we're trying to find. And I can pick out this equation right here as being the one that will help me find acceleration, because the other two equations have acceleration and time in there, and those are two of my unknowns. And so if I only have one equation, I can't solve for those two unknowns. But in here, I only have one unknown, so I can use that to solve for our acceleration. So I'll get v squared equals v naught squared plus 2a s minus s naught. So 4 squared equals 1.5 squared plus 2a 2 minus 0. And if you solve all that out, you'll get A equals 3.4375 miles per hour squared. So that would be your acceleration. And then I can use that to plug it in to any of these other equations to solve for my time. Now this equation is smaller, so I'm just going to use that one. So we've got V equals V naught plus AT. So we'll get 4 equals 1.5 plus 3.4375 T. And you can solve that for T equals 0.72 hours. And if you do conversions on that, that's going to be the same thing as 43.6 minutes. Now, I converted this to minutes here just because 0.72 hours doesn't really mean anything in our mind, but 43 minutes does. All right, so that should be good for that. I'm going to go ahead and try one of these on your own. Let's do a biker. Who starts at rest, travels 200 feet in 25 seconds. So the biker is accelerating at a constant rate. Find final velocity at that 200-foot mark. So you just need to find V. All right, so go ahead, pause the video, work that out, and then check your answer with the PDF solution. This will be number 2. All right. Let's go ahead now and look at projectile motion. So this is any sort of motion that creates like an arch shape like that. So you could like kick a soccer ball, throw a football, hit a golf ball, anything like that. One thing you need to know is that these will have some initial velocity at some angle theta. And then this here would be your total travel distance S. So when you're looking at projectile motion, you're going to have motion in the X plane and motion in the Y plane. So you're going to take those equations that we were using above, so that V equals V naught plus AT, and S equals S naught plus V naught T plus 1/2 AT squared, and V squared equals V naught squared plus 2A S minus S naught. So you're going to take these, but you have to apply them in the X direction and Y direction separately. So you're going to have 6 different equations. So you're going to have these 3 for the X, and then you'll also have these 3, but in the Y direction. You can't combine your X and Y directions because it won't work. You have to keep them separate. So the first thing you're going to have to do for these types of problems is separate out your initial velocity into X and Y components. So if we got this is our V naught, we have this angle theta here, then this would be our V naught in the X, and then our V naught in the Y. All right, so we can see that v naught x equals v naught cosine theta, and then v naught y equals v naught sine theta. All right. And then another thing to know is that acceleration in the x direction is equal to 0. Acceleration in the y direction is equal to gravity. So negative 32.2 feet per second squared. Now, you've got to remember that it's 0 in the x direction because gravity does not work horizontally. It only works up and down, which is our y direction. All right? So once you have those, then you can just start plugging into these equations up here. And you should be good to go. So if we have a golf ball that is hit with an initial velocity of 100 feet per second at an angle of 20 degrees, and we want to find the hang time for that ball, and we also want to find the travel length. All right. So first thing I'm going to do is try to find this hang time here. So how long is the ball in the air before it hits the ground again? I'm going to find that time t. So if I think about this, in the x direction, the two equations that would have t involved would be this one and this one. Now this one has a final velocity in the x direction, which I don't know. And I also don't know time, so I can't use that equation. Now, if I look at this second one, I don't know this. I know acceleration. So I don't know this, and I don't know this. All right, so I can't use that one. And for this one, it doesn't even have t in there, so I'm not going to use that one. So obviously in the x direction, it's not going to work for any of these. So let's go ahead and look at the y direction now. Y direction, I still have too many unknowns up here. But it looks like this one will work out. So we're going to go ahead and just start plugging and chugging for that one. So S equals S naught plus V naught T plus 1/2 A in the Y direction, remember? T squared. All right, so first thing, S final in the Y direction. So we declared this 0. S in the Y direction would be going up this way. So S initial is 0, S final is 0. So both of these will actually go to 0 in the Y direction. And then V naught, so we're gonna have 0 equals 0 plus V naught we found here as being, because it's got to be V naught in the Y direction. So V naught sine of 20. So 100 sine 20 plus 1/2 acceleration in the Y direction is negative 32.2, and then T squared. All right, now if you saw this all out, you'll get T equals 2.12 seconds. All right, and now we want to find this travel length, and that's very obviously in the x direction, so we're only going to use x equations for this one. We don't know that. This doesn't even have s in it, so we're not going to use that one. So that leaves it with this one and this one. Now, if we look at this one, our a in the x direction is 0, which would make this whole thing 0. So we can't use that one because it gets rid of our s, so we're going to go ahead and use this one again. So s equals s naught plus v naught t plus 1/2 ax t squared. Now, if you remember, ax is 0, so that whole thing's going to go to 0. Now we're looking for s. S naught, we can just declare this our origin. So 0, 0 there. So our initial is going to be 0. Plus our v naught in the x. So 100 cosine 20 times time, which we found before. You solve that all out, and you'll get 199.2 feet for how far that golf ball is being traveled. All right, so go ahead and try one of these on your own now. Say we're throwing a football. V naught equals 60 feet per second at an angle of 30 degrees. And we want to know how far the ball will travel. All right. So pause the video, work that out on your own, and check your solution with the PDF below. It'll be number 3. And that pretty much sums it up for kinematics.